3.5 derivatives of trigonometric functions. So it's a new list of rules to memorize, and the memorization will probably come from just usage in homework problems. There are some small tricks I'll try to explain very quickly as to how to memorize them ahead of time. But again, real memorization will only come from usage most likely. So these are, again, rules for particular functions. Like you had a power rule and you had a constant rule for a constant function. So now you have trigonometric functions. What should their derivatives be? It turns out that if f of x is the sine function, then f prime is the cosine function, it turns out. Okay. If f of x is then the cosine function, you would probably then guess that its derivative is sine back again. You're close. Its derivative is negative sine. Tangent function, which is the quotient of these two, sine over cos, its derivative is secant squared. Okay. So those are the main three. And now you have the reciprocals. F of x equals cosecant. Again, that is the reciprocal of sine, right? The cosecant. I'm writing them in the usual order. The three main ones and the three corresponding reciprocals. So cosecant x is the reciprocal of sine. Its derivative is negative cosecant x cotangent x. Those are products. F of x is the secant function, which is the reciprocal of cosine, yet it's the cofunction of cosecant. Watch out. F prime will be secant tan, secant x tan x. And the last one, if f of x is the cotangent function, then its derivative will be negative cosecant squared. There are a lot of relationships in here. I'll just point out a couple very quickly. One, for example, tan, its derivative is secant squared. The cofunction to the tangent function is cotan, right? And it turns out that its derivative is exactly the cofunction of the derivative of the tangent, right? So you have tangent to secant squared, cotangent to cosecant squared. I understand there's a negative. It's also easy to remember which ones have negatives because it's every other one if you list them out in this way, which is a useful way to think about it. But anyway, the point is tangent to secant squared, cotangent to cosecant squared, and remember which ones have negatives. So too, let's go this way. Secant is going to become secant tan through the process of differentiation. So you have secant to secant tan. The cofunction to secant is cosecant, and notice that its derivative is composed of the exact cofunctions of secant and tan. So again, secant becomes secant tan, cosecant becomes cosecant cotan. And again, apply the negative. All right. The same is really true with sine and cosine, but it's so simple that you don't have to think about it that way. But remembering about cofunctions in the relationships can help you to easily memorize a lot of these in advance, even before working any particular problems.